Hello from Bruce, VE3LPR. In this video, you'll see me do a restoration of a Johnson Viking Ranger transmitter. After I got started into it about a week or so, I went online and quickly discovered there's a few people that really know what they're doing with these things. And I just want to give a little thank you and 7-3 to these people for their help. They didn't know that they were helping, but their videos were amazing. Terry at D-Lab Electronics, N6TLU, thank you. And also Buddy, KC4UMO. Just watching you guys do the complete restoration process was so helpful and inspiring. And it gave me a really good idea of what I was in for. Also, Greg AA8V, for the online documentation and detailed notes on how every part of the circuit works. Thank you so much, guys. I don't know if I could have done this project without you, or if I did, it would have taken a lot longer. Anyway, here's a few clips of the process. Thank you again, guys. See you. Hope you enjoy. The Johnson Viking Ranger has arrived. And it arrived in one piece. It was well packed. Inside the cabinet, the tubes weren't secured, but they all managed to stay in their sockets. So just a quick check of the front panel. All the pointers are missing from the dials, but that's okay. I can make something. There is a crystal socket plug, which is great. The band switch works in all positions, rotates the mechanism, the cam, properly inside. Going back to the drive here, that potentiometer feels really good. Let's see here. Variable capacitors feel good. They're all in good shape. Meter switch, the meter itself. No cracks in the glass. Switch feels great. Audio control is a little tight. The big thing, though, and that was described in the sale, is that the vernier feels pretty good here. It's rotating, but then it jams there. Something is blocking it. And it jams there. Something is blocking it. So I'm going to have to pull off the front panel to see what's going on. Looking inside, the pictures showed a fair amount of dirt on the circuit boards, but I'm really pleased to say that dirt is actually just surface grime and dust, and most of it will come off with some gentle cleaning. There is a fair amount of rust on the transformers, which can be cleaned up. All the tubes are in, as I said, and apparently they all are in excellent shape, tested on a really good tube checker. What I did find, however, bouncing around inside, is this capacitor and resistor. I have no idea where that came from. It might have come from the push-to-talk relay that's on there. So there will be some investigation. But the first step is to clean up everything. Probably remove all the knobs. They need to be cleaned anyway. Remove the front panel and find out what's going on with the vernier dial. I don't want to push it too much because I don't want to break anything. It looks like the connection into the VFO is good. And then, of course, rumor has it that I should take the VFO apart anyway and see what's going on with that famous firecracker resistor in there. So, very excited. Looking at the back side,
Looks like a fairly new 6146 in there. Tank coils look in great shape. All the coils look in good shape. I'll flip it around and look at the underside, but it looks like nobody has done any major modifications on it. It looks fairly stock, which is what I want. This power resistor looks to be in great shape. Looks like original filter capacitor. Needs to be changed out, but all the mounts, everything, all the coils look good. Looks very clean. This shielding was bent. Somebody put some weight in this section here. You can see I've got to bend that back into shape, but nothing appears damaged. As I mentioned, the band switch function here, when I step down to 80 or 160 meters, there's 80, 40, and I go up to 10. All looks good. So this will be a big project, but right now, anyway, I'm looking forward to the adventure. Now, before I dig into more cleaning on the top panel, I wanted to see if I could actually loosen the lock nuts on the tuning shaft that's down in this hole. Won't be able to see it with the video camera, but unfortunately I cannot turn the main tuning dial enough to get access to both locking nuts. So that means I have to pull the front panel off and actually I think that'll be more challenging. Anyway, in order to see that, I had to remove this 30 microfarad 450 volt capacitor from here. It actually went this way. I'm actually going to be replacing that for sure anyway. And interestingly enough, you can see that the capacitor was being squeezed by the band switch. It was just squeezed in there. So good thing modern capacitors are so much smaller, so there'd be lots of space there. And again, once the top is nicely cleaned up, then I'll dig into the bottom, but everything appears to be stock, and this is a production machine because the tube sockets are riveted in. So once I'm done the top, I'll dig into the to the bottom section, which will be nice because things look pretty clean here. Now, the question I can't seem to find online is how to actually disconnect this meter, and I'm assuming that there are two nuts that hold on this terminal plate, and I'm assuming that if I loosen those, take those nuts off, and then remove the meter connections here with these two nuts, that I can take the entire terminal strip and these coils off. That's my plan. I'll see what happens right now. So one thing I notice is the rubber gasket that's around the front panel is in great shape. No cracks, nothing. Now, although the panel is very dirty, but it's all very cleanable. There are no scratches or bangs or dents on it. This panel is going to clean up really nicely. I discovered that after removing the front panel, or the front dial indicator, that the vernier is actually working fine, and it actually feels nice and even, which is fantastic. So I have to decide here. I mean, yeah, it would be great to remove the front panel to get access to everything for cleaning, but the process to remove this whole vernier, pointer, and everything like that, I've got full access to clean the front panel. I just noticed the meter, although the glass isn't cracked, but you can see it's fallen in behind. So I've got the meter disconnected everywhere from the back. It turned out that, get a better position, turned out that I couldn't remove those nuts holding on the terminal strip, so I just desoldered the wires. And so I'll figure out how to take the meter apart to fix that. But what I'm hoping is if I remove this relay and CW keying platform, I mean, I have to remove that anyway, that I can get access to the VFO and take a look inside from the side panel, and not have to remove the front. That would be a nice thing. Sure looks beat up, but actually it's just the angle of the lighting and the dust. So super pleased that the dial vernier is actually working really well, and it feels great. No problem. So I learned that to actually remove the meter, you have to remove the back housing first. So I removed the washers and the insulators and everything. Here you can see these are the insulators that slide over the terminals to keep them from shorting to the chassis. So once those are removed, this cover actually pops off. Okay, so, and then I can, I noticed, tighten those terminal screws. So it was a good thing I didn't try to remove the terminal strip with just the screws. So it's loose right now, but I can fix that. And now, yay, I've got access to the 4 bolts that hold the meter in, and I can take that out, give it a good cleaning, and get that glass set back in place. Well, the meter is out, and boy, what a pain that was. On each of the screws there is a washer, a small lock washer, and a nut. And I think this meter was mounted to the panel before the panel was installed, because it's really difficult to get there without removing the panel. But I managed to keep all the screws. The ones that fell, I have a little magnetic pickup tool which helped, except for the lock washers, which appear to be made out of some non-ferrous material. Anyway, let's take a look at this meter, and the next trick. Oh, I see how I can get into it. There are, looks like, yeah, three set screws there, so I can pull this housing off, pull the meter, and reseat the glass. You can see some dirt on there. So, but the nice thing is the meter movement seems good. Otherwise, it's clean. So, fantastic. Inside this area is going to need some work, some cleanup. But again, still hoping to do this restoration repair without having to pull the entire front panel off. We'll see. Okay, so the meter is taken out of the housing. Looks amazing. If I blow on it a little bit there, the motion is perfect. Really nice clean dial. So looking inside, I'll just set this meter aside for now. Looking inside, I was trying to figure out what held this glass in place. And inside you can see there's this metal ring. And there's all kinds of, it's dried up what looked to be grease or something. But somebody pushed on the meter glass on the front. They pushed so hard here that they actually slid this whole glass retaining ring out of position. So I'm going to clean up whatever mess is in there and hopefully be able to slide out this retaining ring and remove the glass completely so that I can clean it and reinstall everything to get this meter completely restored. So if nothing else, this was a learning experience. I haven't seen anything on how to maintain these meters. Okay, let's get this cleaned up and out of here. So now I've got the inside of the meter housing, all the crusted up lubrication cleaned out, and of course this allowed me to clean the sides of the meter right to the edge, so it's going to look really nice once it's seated on the front panel. And of course the glass itself, I'm going to do a final polish, maybe some Windex and then a microfiber cloth, and get that back in there and get this meter back into its case, which will be much safer than sitting out here in the open like this. So in my attempt to put the glass back together and reinstall the retaining ring, I found out that it still isn't held in place very securely, that if I put you know, a little bit of pressure on the front glass, that I was able to move it again. And it looks like, I don't know if you can see it, I'll try and zoom in here, but you can see there was, it looks like some sort of a glue or something, that black line at the bottom of the glass there. So what I'm thinking is that was actually some sort of a sticky tape or something that helped keep the glass pushed up against the top here. So what I'm going to do is apply a thin strip of VHB, which is extremely adhesive on both sides, and I'll attach it here first and then gently put the glass in position, and that should help keep it anchored this way in combination with the pressure from this retaining ring. That's my plan. See how it works. All right, so the glass is now anchored in place with that VHB, and it's pushing it up against the top. It's too bad there's no ridge inside there, but I guess the idea is that this ring is enough of a friction fit that it should hold it in place, and presumably it sits over this, and installing the meter, no, it's not going to hold that in place. So maybe that black stuff around the edge was actually some sort of a glue. Well, The VHB seems to be holding very well. As you can see, I managed to get some fingerprints on there. I removed my nitro gloves because I wanted a little more dexterity when working on this, but it's okay. The glass is in place. I can still clean the visible sides from both sides, and it's not going to fall down anymore. So it's just if somebody pushes on the front side where my thumb is there, there is nothing holding it. So my hope is that this retaining ring is going to work really well. And I guess, you know what, maybe it's a good thing. I mean, I did have to push firmly to get that glass to move, and maybe that's a good thing, because maybe if something hits the glass or something, having it slide a little bit out of the way as opposed to absorbing all the impact, maybe that's a way they maybe that's why this glass is not broken. So maybe that's intentional. I don't know. Anyway, it's sure really impressive to see the quality construction of these meters mechanically, the tolerances, and to think that, you know, this is from the 50s. Well, they sure don't make things like this anymore. Where have you heard that before? And now we have a completely restored meter. So this meter is ready to go back in, but obviously what's going to happen next is the front panel needs to be cleaned up. I'm going to spend some time really detailing that. Also the front dial display needs to be thoroughly cleaned, and I'm wondering if the reason that this vernier got stuck was that this angle might be a bit much. This is my first Ranger repair, so I don't know what's normal, but it seems that might have been pushing up against it a little too hard, causing some friction. So if necessary, I can bend this metal tab a little bit, hoping to be able to do that without having to remove that and disturb the dial indicator calibration. But hey, at this point, I'll do whatever needs to be done. Just take my time and go through it. But yeah, I'm definitely looking forward to cleaning up the front panel, and then also cleaning up these knobs, and then finding some round white material that I can insert into these holes and get some pointers back. Okay, that's enough for today. Time to wind down. So I found out what actually is causing the dial to stop. Is, I don't know if this is stock or not, but there's some black, what appears to be sticky foam or something, and it looks like it got hot and it melted, and you can actually see, if I zoom in here, you can actually see the dial got pushed into it, and then also on the other side there as well. So, and look at that, it's sort of seeping into the text there. Yeah, so I'm going to see what's necessary. I guess that is the goop that holds the indicator plate in place, and looking at it, that's not plastic, that is made out of glass. That's impressive. So I have to be very careful when cleaning. I don't want to mess up this text, but obviously I'm going to have to do something to get rid of some of this material. Yeah, and hopefully not drop it too many times. And what I might do is just use an X-Acto knife and cut away just the portions that were interfering with the dial. But actually it looks like, yeah, it looks like I need to cut a fair amount of material away there. Yeah, something, this rig must have been hot at some point. Anyway, that's another project. Okay, I've got the keyer platform off, and you can see that big capacitor that needs to be replaced. There's some really questionable wiring that's going on to the contacts, and even down the splice there, even down to the switch. So I will clean up that that switch and contacts, make sure everything's fine. One of the posts here was completely separated from the chassis, and this one's loose, so that needs some tightening. But the good news is, if I'll shine some little bit of light here. If I look inside the VFO, things are looking in really good shape. Super clean. This 18K capacitor, or excuse me, 18K power resistor doesn't look cooked, which is fantastic. The tubes look good. Nothing has been overheated in that compartment. And then even if I go inside and look at the coils, you know, everything is looking just fantastic. So, yeah, this rig, you know, it needs help in some areas, but it looks like in the core areas, in the important spots, it's in good shape. So looking under the keyer platform, this label's been damaged a bit, but serial number, can anyone read that? Looks like a 680. I'm not sure. That black mark on the end is a 2, if it's a 4-digit number or if it's a 5-digit number. I don't know enough about these radios. Maybe somebody can comment, but it certainly looks like the serial number starts with a 68. Just not sure if it's 4 or 3 digits. Anyway, carrying on. I started some front panel cleanup just to see how good things look, and yeah, as you can see, things seem to be in pretty good shape. So this was just a quick wipe to see what's going on. The big project for the last little while, few hours actually, has been restoring this dial scale plate. It's almost clear. There's still some spots to go, but I'm impressed. So I wound up actually using naphtha to dissolve the black gunk that was there, and I tested it on a spot to be sure it wasn't going to cause any damage to, this is plastic. I thought it was glass at first. So used the naphtha to break down the black gunk that was there, and then to actually remove the underlying adhesive that was there using 99.9% isopropyl alcohol. And that just dissolved whatever adhesive tape that was there. And then the final polish was with good old glass cleaner sort of Windex and clean cotton rags. So still more polishing to go, but once everything is in place, this dial I think is just going to glow. I also polishing the sides so that the dial panel lamps are going to really be able to illuminate there because these sides were all covered in that black stuff. It was almost like the owner intentionally wanted the lights not to illuminate the dial. I don't know. Anyways, some more work, but this has taken a few hours so far just to get this so clean. And again, I'm impressed with the condition of this rig so far. I hope it works. So on the keyer board, this big nasty old capacitor, it's kind of dried up. I replaced with a 33 microfarad 250 volt capacitor. The other one would have been 30. It's fairly close. And double checking that the positive is connected to ground and the negative is going over to the high side of that 4.7K voltage divider. I just used the old wire going to the capacitor, the blue wire. All the resistors check out within tolerance, so that's good. I'm just going to see about this capacitor and see how that thing is doing. A big part of the restoration is going to be tube testing. I'm not going to spend a lot of time going over that because there are, there are a bunch of videos, people using their tube testers. So anyway, this is an ICO 667 here. And the ones that I was most curious were, this unit came with a pair of 1614s. And apparently they test great. So I'm just going to do a quick test here. And just so you can, if you haven't used a tube tester like this one, we'll just go over it. So I'm looking in the database here for the 1614 tube, and I'll just go through the settings. So filament voltage is 6.3. The grid setting is 91. Turn that there. The plate is 1614 is 76. Okay, and then we've got the levers here. So I'm going to go through 6143, 6143, 562, 562. I've used a bunch of tube testers in my life, but there's something really cool about these levers. Okay, so I just got to double check. I'm using the same two. 1614. So 6, 1, 4, 3, 5, 6, 2. Okay, the second bank of levers are all ones. Okay. And the V lever is at 4. And S is at 1. Okay. And then we're going to be checking 3, 4, 5, and 8 for leaks. And the merit, the health of the tube will be position 3. So with this tube tester, we're going to first of all turn it on. You can see maybe a red light up there, and I already know that the line voltage calibration, I can just quickly push this, and if it's in the center there, that means the voltage is calibrated. So we're sitting exactly 120 volts. So let's plug this into the socket, and we'll wait for this thing to warm up. Okay, I've waited a minute here for this. So we're going to test leaks on position 3. Good. Position 4. Good. 5. And 8 is going to be reverse, and then I just do the HK leak. That should go. There's a little bit of a leak there. Okay, not great. Anyway, let's test the merit. I'm back to position 3 here, so I put it back to 3, and then I do the merit, and we see, wow, this tube is in excellent shape. So it's in the was around a little under 110 there. So okay, so there was a little bit of a leak in position 8. It was a little bit lower now that it's warmed up. But let's reset, and I'm going to pop in the next tube. I'm just going to label this one as a slight leak in position 8, and let's test the other tube. Wait for it to warm up. Give it a minute or two. Okay, and from the previous tube, the leakage, inter-element leakage, was very low. It was somewhere around, looked like 5 megohm or something like that if I look closely on the dial. Anyway, we'll test this second tube. So we go to position 3, 4, 5, good, 8, leak. Okay, so this one's got, that's 5, a little bit of a leak as well. So both of them are consistent. Then we'll go back to 3, and we'll measure the merit. And that is pretty much exactly as the other tube. So we'll see. Both of them have somewhere between 5 and 10 megohm of leak. Call it inter-element leakage in position 8. But they're both the same. So I'll power that thing off, and I do have two matched 1614s that have equal amount of performance and a little bit of leakage. So we'll see what happens when the day comes that I get the Ranger all fired up. I'm just working in the low voltage power supply area. So this 30 microfarad capacitor, that huge capacitor that was going from here all the way, covering the access hole for the VFO dial. So that was replaced with a 47 microfarad 450 volt capacitor. And that capacitance should be okay for that rectifier tube. I think it's a 6AX5. So that should be good. Down in the audio section here, I am preemptively replacing this 0.02 microfarad coupling capacitor to avoid any potential future problems. These other 0.1s I'm not worried about. They look very healthy, and they're just bypass capacitors to ground. The challenging part here will be these two 10 microfarad capacitors that's going here. I thought I could maybe clip out this clamp, but it looks like I will have to grind it out. But what I did notice, I went through this entire rig and measured resistors, and these ones, they're supposed to be 470 kilo ohm, They're between 520 and 530 kilo ohms, so I've got to replace those as well. Just a little detail of my process of replacing components. Rather than cut off this bad resistor or capacitor or whatever I'm replacing right at the base or at the tube socket and disturbing all these connections here, I cut the bad component out right at the component's case itself, and that leaves me with a wire. I can cut back the insulation, and then you can see, this camera's great, I can zoom in. I hook the wire over, and I do that on both components. And then before soldering, I'm not sure if that's in focus or not, but before soldering, I can have a good mechanical connection, and then the solder will obviously hold that all together. And then that way, I don't have to be messing with terminal strips. You can see when this will be the other end of the resistor connection here that I'm going to hook through and then sort of crimp both ends. And again, if I was to go up and start trying to replace that stuff at those terminal strips, that would be messy, would disturb perfectly good solder connections. So that's the kind of way I prefer to replace components. And that's the result of the first 470K resistor replaced. Okay, so good clean connection to it. The other thing is, going back into the radio at a future time, it's really easy to see what components were modified or upgraded, and then if something needs to be swapped again, hopefully not. I mean, these are new components, but it would be clear to whoever else is working on this radio what was done. Okay, so I've got this capacitor mounting strap cut with a Dremel tool. It was a little nerve-wracking because I had the vacuum cleaner there to try and catch some of it, and obviously being so close to this audio transformer that I didn't want to destroy. So challenging to say the least. Anyway, I'm going to have to get some larger pliers in here or something to get this capacitor out. I don't want to. Well, I don't particularly care about the capacitor, but I think I'm going to have to use two hands to bend these clamps. The way I've got the bench set up, it's very hard to get a tripod in here, so I'm doing my best to hold the camera steady so you don't get dizzy. But you get the point. So I'm going to remove this capacitor and then have good access to the ground there to solder in the two nice and small 10 microfarad capacitors. I just noticed the audio input section here. It's a mess. So there's the 300 picofarad capacitor, but if I can zoom in with this camera, you can see that the center conductor is very dried and cracked, and actually when I found it, the shield was strands of the shield were touching that. So I'm going to have to peel that back and see how bad it is. Seems pretty good further back. I do notice that there are two open terminals here, so maybe I can cut back the audio cable and put the shield and center conductor on these terminals. But what really is strange to me is look at the location here of the audio input And then look at here. This is the final power amplifier, RF power amplifier coupling capacitor, variable capacitor. Okay, so that's an inch away. I don't understand, and there's no shield. I mean, you know, the audio is bypassed, but boy, that a little disc capacitor must be taking, or no, excuse me, this 300 picofarad capacitor, that must be taking a bit of heat there. Anyway, I just don't understand how a low-level audio input, high impedance low-level audio input, can be located right next to a 40-watt RF output coupling capacitor. Makes no sense to me, but I guess it works. Be curious to see what kind of RF is on the microphone line, but I guess the cable is shielded. Yeah, shielding in this radio is minimal. I've removed the shield that needed to be bent in position, but I guess when it's in its cabinet, it's okay, but wow. We'll see what happens. Well, I did it. I pulled off the front panel. The vernier lock nuts, I was able to get at them, of course, and they weren't super tight. And just feeling the vernier on its own, it's really smooth. The main reason for pulling off the front panel was to be able to get at this switch here. The wiring that is going to the old relay is so dried out and brittle, and I have to make connections. Let me focus on getting this camera in place. I have to make connections to these switch contacts and clean up the mess whenever this was installed. I don't think the person took off the front panel and they just kind of squeezed a soldering iron in there. So it will allow me to get at that, clean up, put some really good silicone wire in there. Of course, I can do some better cleaning, especially over here in the audio section. I can get at the wafers a lot easier. And then eventually, in the next little bit, get at that firecracker resistor there and replace that. So I wound up getting some a metal film 7-watt 18K flame-proof resistor. So this is not carbon, this is a metal film resistor, and it's a little bigger than what's in there right now, but that will work. Anyway, I had a fear of taking off the front panel, and I was so close, so I just thought, you know what, let's conquer the fear here, let's do this, and now I can get full access to clean the front panel really nicely, and then do a better cleaning job of the chassis here, and ultimately just have full access to things to replace things and do it right. So I might as well. I'm into it now. Just keep going. Now I'm digging into the main control switch, all the brittle and broken wire with the front panel off. It's much easier, but still, I mean, getting to this one connection down there to pull off this wire might be tricky. Some cleanup to do there. You can see the condition of the wires, just not great. So let's see what happens here. So just cleaning the band switch right now. Naphtha does a great job of dissolving all the black grime off these contacts. Let me see if I can get to this back switch here. There's some lighting here. I don't know how much you can see there, but compared to the all the black gunk that was on the switches, it's much better now. Oh, I see I've got some residual cotton swab stuff I have to take away there. Okay, proceeding to the top switches. Okay, the all-important resistor in the VFO is changed. The carbon 2-watt firecracker was removed. And you can see I installed an 18K 2-watt. And again, my technique of hooking the wires together. And I chose to do that especially for the tube socket. Fortunately, I was able to get in with the soldering iron to do this without having to take off the top of the VFO case. Okay, moving on to switch cleanups on the top side, and then I can start to get this keyer platform moved into place again and put the cover back onto the VFO. You can see I've got the silicone wires that are going to go to the new relay. I've got that all set. I'm going to also try to do a little bit more cleanup on the chassis as can. I've been staying away from this tag area, but yesterday it looked like the serial number was in the 8,000 range, but I have no idea. Oh, hey, one thing I noticed, kind of glad I caught this, but look at in the position here of the high voltage rectifier tube. It's marked as a 5U4, and there was a 5U4 in there. So I don't know about that. That tube has an extra 1 amp of current draw at 5 volts. So, I mean, it was obviously in there and used. And this transformer can probably handle it, but anyway, I'm going to try and find a proper high voltage rectifier tube. And one of the final stages of the reconditioning will be to resurface these transformers. This is the planned replacement relay. It's a 240 volt coil, 250 volt AC coil. So for mounting, I took a Dremel tool and I just cut slits near this mounting screw on both sides, and then lifted the plastic tab up, and it broke nicely. So I'm going to see what kind of thread that is. Hopefully it's a thread and not just a plastic screw, and then I can use that to anchor this this new relay down. Anyway, the coil resistance on this one measures a little over 9 kilo ohm, so it should be close. Turns out the mounting screw on the side of the relay was a plastic screw, but it was the right diameter that I could cut some threads, 632 threads, and get a fair amount of material in there to have a solid mount for this relay. So what I like about this mounting, for me especially, is that there is the pinout there. I mean, I can easily see with this size of relay, you know, what's going on with the contacts, but just to double check. Anyway, compared to the original relay, this will be nice, and the plastic case will keep the dirt out of that thing. And this thing makes quite a nice sound when it engages, which is important when you key up a transmitter, right? Yeah. I was going on about how I couldn't believe that the plate loading output capacitor, or the final PA loading output capacitor, was so close to the audio without any shielding, and it turns out that there's a shield missing. There's 2 holes there and 2 holes there. So the shield is missing, and this whole audio section is a mess. I did find a piece of aluminum left over from years ago. I think this was from a old Radio Shack box or something. And it just so happens that the height is going to do the trick, right from the bottom of the chassis. Fairly close anyway. So the plan is to see if I can fold and bend some aluminum and construct some sort of a shield, and have the key, this new silicone wire here, that's the push to talk, and I'll clean up the shielded audio cable to the input of the audio amp. So, shield construction time. Okay. That piece of aluminum turned out to be exactly the size that I needed. Goes right up to the top of the chassis, and as you can see, there's enough clearance for the. I guess that goes to the modulation transformer. There's enough clearance there for those wires, and yeah, the compartment is small, but the shield can be put on afterwards. So now I just have to go to the back side and mark the holes on the piece of aluminum and on the side of the chassis as well. And then figure out what I'm going to do to feed this wire through. I'm not sure if the best solution is to cut a slot in this thing. I'd like to try and avoid that. Getting a soldering iron in there might be challenging, but I would like to just have a hole with a grommet there that the wires can go into as far away as possible from the loading capacitor. And yeah, you can see that line there. That was my first calculation of where to bend it. Good thing they have that saying, measure twice and cut once. Or in my case, measure 5 times and cut once. That's generally what I find best for me, that works for me to keep from making too many mistakes. Even then, I still make mistakes. So I think it's really amazing that there's this piece of aluminum that's been sitting in a junk pile for such a long time that hasn't had a use, and it turns out to be a perfect RF shield for the audio input. Okay, carrying on. Okay, getting the audio input section cleaned up. Managed to clean up the shielded cable, and there's enough length there, I think, to get inside the shield, and that part of the wire there doesn't look bad. It's not crumbling or anything like that. So the challenge here is just to decide how I'm going to cut a little access hole. The idea of using a through hole then makes it a problem for removing the shield. So I think what I have to do is cut away a section here and then just have a little circle, just large enough excuse me, cut a circle up here and have a hole that's just large enough to let the shielded cable, CW key, and push-to-talk lines through. Let's see how it goes. Okay, so the plan is I've cut a small hole there that's just big enough to fit the shielded cable through. And I'm going to keep that all shielded. And then there's a gap on the top, which is plenty wide enough. Once the shield is bolted down, you can see that gap between the bottom of the chassis and there. So I can put some good heat shrink tubing on top of the push-to-talk and CW cables to go through and just connect directly to the microphone connector. And that way I'm keeping the audio separate from the other lines. I think that will help. So aluminum isn't quite bent yet, but once it's in place, I think the clearance for the wires to the modulation transformer, everything's close there, but it's enough room. Nothing is shorting to the connector. It's close to that terminal strip, but it will work. And most importantly, I'm far enough from the loading capacitor there. Okay, carrying on. So here's the audio input shielded cable splice. Okay, so the center conductor is heat shrunk underneath there, and then I slid the braid over the other one. And so this whole section now is going to have a piece of thin heat shrink installed on top, and the actual solder connection will be inside the shield, but the heat shrink is just going to protect this area a little bit. Seems okay, but I'll just cover it up with something. And now we're looking at the modified audio input. So I made a new ground ring connection, and so the capacitor for the relay connect there to the ground, and then the 300 picofarad capacitor from the microphone input to ground. Everything's very sturdy. So now the last connection to do, at least at the microphone connector, is to wire the hot of the microphone input there. And what I'll probably do is just leave enough so that the hot can go there, but then I can tie the shield to the ground, to this ground wire on the 300 puff capacitor. And then after that, I just have to extend the CW key wire, and then have it route into the shield, underneath the shield, and to this choke here. And then I can button up this area. And here's the completed audio section. So I've got the shielded microphone cable connecting to ground as well, and the CW line going to the choke. Just zoom in detail there. So now I can install the shield, and move on to the next section. Lots more to do. Well, the next area is the AC input power cord. Soldering is pretty bad. Frayed wires, just globs of solder, not heated properly. The grommet was completely dry, and the power cord, original power cord, was badly cracked. The plug itself was badly cracked, exposing the fuses. So that's not useful. So I've heard a few things. Some people say just put a polarized plug on here, and others say grounded. The chassis is isolated, but personal experience has taught me that there can be some ground leakage on this kind of stuff, and even though it's maybe just tens or maybe 50 or 60 volts, I'm not interested in feeling any of that if I happen to be touching the chassis and then something that is actually grounded. So I'm going to install a grounded power cord. Now I'm not going to disturb things here and put a fuse or anything like that. So what's going to happen is there's going to be a grounded power cord feeding in here. And then there's going to be an external little box. I found an old dual fuse holder here. I'm going to repurpose. It's a nice big piece of Bakelite there. I'm going to put in an enclosure, and that will have the two fuses, and then it will go to the grounded line cord. That way I know that the chassis is at ground potential, especially firing up this this radio that I don't know when the last time it was on, in case there are any problems. I don't want anything touching the chassis that's not at ground potential. All right, into this. Okay, the relay is now wired and installed on the keyer platform, and I've got the wires bundled down to stay away from the 6AX5 rectifier tube, and that numbering scheme is just for my own identification, but I will document that. Now, with all the switches cleaned up and the chassis cleaned up as best I can in the front areas, in these areas here, all the knobs and switches appear to be working. The drive potentiometer on the left, that's working well. The audio pot on the right just needed some lubrication. So I'm ready to put the front cover back on again. The vernier set screws are recessed enough, hopefully, for that to work. So I've got the front panel cleaned up, ready to install. It's not perfect. I'm not going to worry about certain little scratches or blemishes or anything like that. That's fine. I'm not going to go into that much detail, but considering the shape that this unit was in, I think the front panel is doing really well. And looking at these areas here, this is behind where the area that you really can't see anyway, and that's left over from that black gunk that was on there. So I'm not sure why. It might be a lighting thing. I can find out because the lamps stick out through these holes here. I'm going to find out, and the nice thing is that this front panel and the pointer indicator can be installed afterwards, after the front cover is all mounted and everything like that. And if I need to add some light blocking material, but I think you can see there's a reflection from the light there, but I think the panel's in good shape. So, ready to put this back on again and make it look a little bit more like a Ranger. The tricky part is this set screw that's in the VFO. And so, fortunately, it's sitting exactly where it was before. And so I'll get a screwdriver in there, set that one, then rotate 90 degrees, set the other one. I did have the dial roughly in the halfway spot before, and yeah, just have to be careful with the screwdriver and make sure that the screwdriver is perfectly centered on the slot, and I can get not risk damaging that set screw. So I got it, and as you can see, oh, I got to grab the VFO shaft here. Oh, it just went out of focus. See if I can get the camera to... There we go. Okay. It's a little out of focus, but VFO shaft is turning nicely. You can see little scratches from when I tried to get that screwdriver in there, but I don't think I damaged the heads. See, there's an advantage of using like a, I guess back then they didn't have Torx, but maybe they didn't even have Allen head screws. But it would be nice to have a long tool that you can just put in there and you know it's in position. But slot screws at this distance with this limited angle, tricky. I hope I don't have to do that again so soon. Oh. The next project will be thoroughly washing these knobs. Fortunately, they're in great shape. There's no missing pieces or cracks or anything like that. They just need attention. And so, not sure how to do that. I might just remove the set screws from all of them and soak these things in soapy water, brush them, and then dry them out. Completely dry them out, and then just put a slight little minute dab of lubricant before putting in the set screws again. And I have to come up with a solution to install some sort of a white pointer on these things again. I read somewhere in a forum there was some sort of a white standard material, but there's got to be some white plastic round stock or something that I can use. So as I mentioned at the very beginning, fortunately this radio has the oopsie, that's a good way to scratch the front panel after all this work. The crystal cover looks like a knob. One surprise that I found when I turned it upside down, looked on the back, was a call sign. WA6UZA. I will tell a little story about that later in the video, but I did some online searches and found a very interesting story. So I think I will contact any remaining family in case they might be interested. If this project does turn out to actually work and be successful, and this video actually is shared because of the project's success, it will be nice to have a little video to send to the family of where this radio is now. All right, cleaning. So this is the new AC input. Okay, I've got ground going up to the main accessory output, ground jack. Okay, neutral is going over here, and that goes to the external relay socket there. And the reason I put hot here is if you trace this path, it goes over to this choke, capacitor to ground, and then this choke, and then you can see it goes to this terminal strip, which goes to this black and white wire, which is the main power switch. So I am switching the hot, which I think is normally done. And then, as I mentioned, because I don't want to put any additions into this rig or drill any holes or anything like that, are coming out into a little box with a power cord. Inside here are the two fuse holders that I showed you, and so it's a way to protect the rig without doing any modifications. So I wanted to double check this power resistor, and I noticed when I measured this time that there's nothing on the center tap. I'm measuring 30 kilo ohms from end to end, so that's telling me that the resistor is good. But when I took off the movable center cap, you can see, I mean, I've already started scraping some of the rust off, but that contact was completely pitted. So I'm going to try and clean that up and see if this resistor still actually can make contact in the center. I'm hoping I can save this resistor. Right now, finding something like this is very difficult. There doesn't seem to be stock. So we'll find out. So you probably, people that know, in the previous clip I was saying the resistance was 30 kilo ohms, and this is supposed to be 20 kilo ohms. So this resistor is open. Fortunately, I did find a part on Mauser, 20 kilo ohm, 50 watt, adjustable. That's on its way. So it's a good thing I double checked that, because that would have caused some problems when it came time to firing this thing up. Well, don't want to know what could have happened. In any case, what I'm going to do, I said I measured between ground and here in circuit, I measured 30 kilo ohms. And so that is still the case when I measure where this resistor was connected to. So I'm just going to educate myself to be sure that that 30 kilo ohm measurement makes sense, depending on where things are going. So I'll take a close look at the schematic and make sure that all makes sense. Glad I double checked. Okay, so that 30 kilo ohm resistance across that adjustable power resistor, I traced the circuit back, and obviously there is no center tap connection. So to ground, I'm getting 30 kilo ohms when the operate switch is off, but when I change it to other positions, it's open. So interesting. When it's in the off position, again, I'll have to double check where that's going through, but maybe that's, it certainly is a maybe convenient quick bleeder resistor. When you turn this rig off, it will slowly pull some juice from the capacitors. For the high voltage capacitors, I have two 22 microfarad 450 volts and some 2 watt 470K resistors. Instead of gluing them onto the transformer, I don't want to damage this transformer. So I was looking at these two remaining posts that are here, and I noticed that the bolts stick up higher than the top of the transformer, and I thought, well, it'd be nice to have some sort of a little plate that maybe I could attach this mounting clip to, and then strap the capacitors on, and then this whole assembly can be removed. I thought, well, I've got to cut a little piece of aluminum. So I looked in my aluminum scrap bin, and I found this piece. And I'm not sure where it came from. The holes are a little offset. One of them is slightly larger. But if you notice the way these posts are aligned and the way these posts are kind of bent, it turns out that this piece, right from my scrap bin, is almost a perfect fit for this purpose. And I thought that was kind of nice to see something like that. I guess it was meant to be in this radio. So I'm going to drill a hole in the center and put this flathead screw, maybe a little bit of a countersink in there, and that way these capacitors can be securely mounted, but I won't have to damage this transformer. So what the plan is, I've joined the two capacitors, negative to positive, and soldered these two wires together. So now I'm going to put some glue heat shrink over the center section, which will give it some strength, but also this is going to want to poke through the heat shrink. So after I shrink the heat shrink a little bit, I'm going to poke a little pinhole in there and allow the heat shrink to kind of sink down in there, and this center tap of these capacitors will stick through, and that will allow me to, I want to grab just one resistor here, that will allow me to connect the balancing resistors on the output to the center tap. Then I can trim it down and then put another small piece over heat shrink to cover that center conductor a bit. I'll probably also put some insulation on these wires as well. Getting fancy, but since I made a fancy mount for it, I might as well do fancy connections, hey? And oddly enough, that actually worked to plan. So I got the center tap there, and with this thick-walled glue heat shrink, it's quite sturdy. So resistors next, and then a center insulator, and this thing will be getting closer to mount. And we're almost finished now. Of course, I put this one 470K resistor a little too far to the left, and had to bend this negative lead. That's a bummer. Now you can see the high voltage capacitor, series capacitor network with voltage balancing resistors all mounted in place. In order to keep that plate sitting flat, I just had to add an extra nut above there. It's sitting a little high, but that's okay. Anyway, it's very sturdy and removable. And again, I didn't want to disturb the original transformer with glue, so I just have to remember to hook up the wires. Too bad this wire wasn't a little bit longer to go directly to the ground terminal, but I will figure that out. And tomorrow, it looks like the power resistor, the 50 watt, 20 kilo ohm power resistor will arrive. So I will see how that fits in there, and then at the time when I redo the connection to the tube socket back in there, I'll connect the positive. And then of course I will quadruple check that I've got my capacitors with the right polarity there. Alright, the new 50 watt 20 kilo ohm power resistor is in place and secured. I've for some reason it didn't come with mounting clips, so after taking some time to remove the one way back in here out of the tube socket, I removed it thinking the new resistor would come with new hardware. I had to put that back in. So anyway, I've just kind of set it where the other one was before. It'll need some adjustment, maybe. It's amazing how fine those wires are. I don't understand how they can. I mean, I was very careful when I clamped this down. Yeah, I just carefully rotated the screw until this thing, you know, was secure. But wow, when I think of how fine those wires are. Anyway, it still seems fine. And then, as you can see, here is the new high voltage capacitor, two 22 microfarads in series with two 470 kilo ohm 2-watt film resistors, and then going right down the ground, going right down to this terminal here. So that should be good. I'm at the stage right now where everything is set to go. Oh, I also chose to replace this, I guess it was 0.005 microfarad. I think this is probably close enough. 4700 picofarad. So I replaced that interstage coupling capacitor as well as the 0.02 microfarad capacitor. So that means pretty much every capacitor except these 0.1s here, excluding the ceramic discs, have been replaced. So it looks like electrically I'm wrapping up here, and it's late in the evening now. What I'll probably do is prepare things for careful power up tomorrow, and the plan is to use a variac, but I am going to pull out the high voltage rectifier tube so that I can see that the low voltage is working fine, and then check the up here, check the audio section, make sure it's good, check that I've got good signal into the modulation tubes, and then just take it from there. So at least without high voltage, at least it's funny to think high voltage and they consider 300 volts low voltage, but I'm hoping for it to be carefully done with no light shows. That would be nice. So that's it. I'll give it another look over tomorrow, but wow, this was a project. To be continued here. So, going over everything. So, double checking the top. Got all the tubes in the sockets, except the rectifier tube, high voltage rectifier tube. I think it looks a little cleaner than when I first started. Now the front panel. Wow, you can even see the reflection of the camera. I'll maybe change the angle a little bit. But everything is looking good. The VFO, just really nice and smooth now. And of course, full travel. No problem. Very quiet. So, and for the pointers, I don't know if you can tell from here, but when I zoom in, I'll maybe go into the band switch one here. from a distance they look okay, but as I zoom in, you'll be able to tell what I did. I wound up using, actually, I think it was number 16 stranded wire, and I just stripped off sections, and they fit snugly in those 1/8" holes. So I'm going to think of something to plug those holes a little bit, but from a distance it's working. So you can see the metal front panel itself is really smooth and great condition, but the meter panel did get some rust happening here. So I didn't want to start brushing that or doing anything to ruin that. And again, I got the dial indicator so perfectly clean, so looking forward to seeing that with the backlight. And then also the meter itself here, with the cleaned glass in place, everything. So looks good. Again, hopefully tomorrow I can slowly power this thing up, and there won't be any surprising light shows. I don't think so. I've gone over everything, tested everything, so we'll see what happens. Alright, so everything is hooked up. I've got some wires going to the filter capacitors on various points to monitor voltage. So the far left meter is going to the output of the 6AL5 to see the bias voltage. Then I got the low voltage 300 volt, and then the high voltage here, and then over here is the variac. So I'm just going to review everything again, and we'll see what happens. So looking at the schematic, there are a few things that happened when I first fired up the rig to see what was going on after doing all the recaps. The first thing I mentioned was over here. The radio came with a 5U4, and it's just random that I checked the tube. I assumed it was the proper 5R4 rectifier. So while I was waiting to acquire a 5R4, my first test was with the 5U4, and so the specs show that the heater current on that is 3 amps instead of 2, so that's a stress on the transformer. But I figured the radio had that tube in there anyway, so it was probably used at some point. So I adjusted the bias resistor for the 5U4, and so when I replaced it with the 5R4, the high voltage dropped, and so I had to readjust. that resistor. I had to actually move it up to increase the bias voltage. So that was one thing. And then now moving over to the audio input section of the schematic. As I was testing and tuning the radio, I noticed that there was random noise, just crackles and pops that were showing up. And this was happening even in standby. So as we know, the audio section is on all the time. And when I put it on phone, when I was looking at the modulation section, even without transmitting, I was seeing the needle jump up occasionally for some noise. And so I had already replaced this 0.2 microfarad capacitor, and I thought, well, okay, this is coming in, something is happening in this section here without even me transmitting. So I knew that the tubes were good because I had gone through all the tubes. I think I had a video section of that. And then I was thinking, okay, well, what capacitors didn't I replace? Well, there was the 0.1 microfarads in various places. And I thought, well, the chances of those causing a problem. And then it occurred to me that there's this C52. It's a 500 picofarad capacitor. And so if that capacitor starts breaking down, there's essentially plate voltage here would start going into the 1 megohm variable resistor
the audio gain resistor. I think my pencil is drawing on the schematic a bit. I better be careful. So what I did was replace that capacitor, and the problem disappeared. I also preemptively replaced the 0.1 microfarad capacitor here, right there on the grid of the modulator tubes. I did that. And then also the 0.1s here and here. There's one here. And where is the other one? Oh, I don't recall offhand. Anyway, it was these big round green capacitors. So those are all replaced now. Everything is working well. I also did an experiment because I had read something online. Somebody was saying that you can increase the audio bass response by increasing this to 500 picofarad to a 0.02 microfarad. And there's a very detailed article. I'll put that in the notes. Anyway, I did some tests and I found that the audio was much too bassy and it rolled off the high end too much. And then I dropped it down just as an experiment again. I dropped it down to 2200 picofarad, and I still found the same issue. So I went back to 500 picofarad, and yes, it sounds very narrow and communication radio-like with a crystal microphone, but with a condenser microphone, there's more bass response, and I think it works very well. So I think the people that engineered these circuits came up with this value of 500 picofarad for a good reason. I think it's just to limit bass frequency response, and then also just accentuate the highs a bit, but not too much. Anyway, things are running now, and compared to when I started about 6 weeks ago, I think I know the schematic almost off heart now. Well, maybe I don't, because I couldn't identify where all the 0.1 microfarad capacitors are, but I certainly understand how this radio works. It's amazing what happens when you do a restoration project like this and you start troubleshooting things. You really get to know how a radio works, and it's a lot of work, but in the end, very rewarding. All right, let's look at what software-defined radio says about the signal coming out here. Test 1, 2, 3, 3, 2, Victor Echo 3, Lima Papa Romeo, VE3LPR, testing the Johnson Ranger transmitter. So we can see the bandwidth here of what's happening. Testing 1, 2, 3, 3, 2. Hello, test. Here's the test setup for the Viking Ranger now that it's all operating. The antenna relay is back here, and so it's a very large one, built for lots of power if necessary. So on the bottom right is the 24 volt DC control for the coils. This is an RF output. It's just a little loop that's near the transmitter antenna so that I can patch into a scope to monitor the signal. And when I hit the standby button, relays engage, and I have a light that's on. And what happens at the receiver is that the receiver gets, I don't use the mute function, but what's the other function on the back of the call-ins? What it does is just essentially turn on the AVC circuits, and then when I take the rig out of standby, goes back to normal.
This is the control here for it. Okay, so I can select multiple mic inputs. And the idea for this is that on the Johnson, as many people know, the push-to-talk modification that's outlined in the manual has potentially a couple hundred volts sitting on the mic switch contacts, and so that eliminates this box eliminates that the Johnson control plugs into or this cable plugs into the Johnson control, and then I can have two different mic inputs to select, and everything is 24 volts, which is a little safer. So this is the microphone I'm using here, and this one is modified with a condenser mic input. So when I hit the standby button, antenna switched to TX, and then that enables the push to talk. So the push to talk function will not engage unless this is in standby. So let's get the scope set up and the camera set to look closely at what's going on with the Ranger and its signal output. Okay, the scope is set up right now to just monitor the audio modulation frequency. So time is 1 millisecond per division here. So I'm going to key the transmitter. Got about 45 watts output, and then when I speak to the microphone, testing 1, 2, 3, VE3LPR, Victor Echo 3, Lima, Papa, Romeo. That is the waveform. And then if we want to see the actual carrier waveform, I've increased the scanning frequency now, so it's 50 nanoseconds per division. And so what we're looking at here is the actual 7 megahertz, 7.295 megahertz carrier, and my voice is modulating that carrier, and that's what it looks like. So let's look at the power meter at the dummy load. Okay, the radio is tuned up for 130 milliamps plate current on the 6146, and there's the current. Yeah, it looks like about 40 watts. The camera angle is a bit different perspective. Let's look at peak now. Test 1 2 3 3 2 1. Check test 1 2 3 3 2. The peaks are well, they're showing on the meter about 200 watts. Not sure how accurate that is. I'm pretty certain that I'm not overmodulating. So let's look at the Ranger itself and see what's going on. Okay, let's get this thing. We're in the plate position right now, push to talk circuit, so there's a little bit of idle current there. Let's just go to the grid and look at the drive level here. That's a little low. Okay, let's increase that a bit. All right, go to plate. Yeah, we're dipped there. Okay, and let's look at the modulation. That's the standby. Now we're going to modulate. Test 1 2 3 3 2. Check. Hello. Test 1 2 3 3 2. Check. 1 2 3. Victor Echo 3, Lima, Papa, Romeo. Testing into a dummy load. So it all seems to be working. I'll just have a little summary of the issues that I found when first firing it up, but otherwise, looks like we're on the air.
But it's hard to beat the good old iron, and you've got some sitting in front of you. VE3 Lima, Papa, Radio, Victor Echo 6, Charlie, Quebec. Go ahead.
Yeah, very good, Rick. V6 CQ from VE3LPR. Yeah, the band improved a lot. So yes, you are my first contact on AM. This is actually the first time that I've used this mode of communication, and I wanted it to be on a vintage radio, and I spent a lot of time restoring this thing. 7-3 Rick, I hope you still copy. V6 Charlie, Quebec from Victor Echo 3 Lima Papa Romeo.
I missed bits and pieces of that. I heard that you were in Alberta for 17 years, but I didn't hear what you were doing or where you were. It doesn't really matter. We'll pick this up another time when the band is better, Bruce. But I'm very happy, and I'm so pleased to work you on your very first AM contest ever. And you wanted it to be on a vintage piece of equipment. This tells me that you are excited about radio, I can tell you that. You're not just looking for the easy way to get on the air. Thank you.
Okay, remember when I was cleaning the knobs on the Viking Ranger Restore, I discovered there was some writing on the crystal socket plug, and the call sign WA6 UZA was there. So I did some looking online, and if this call sign, Uniform Zulu Alpha, is actually the person that that may have owned this this transmitter, that was the late Dave, WA6UZA, and I did some further digging and found out that his call sign had changed later on. He got the call sign N6 Romeo Zulu, and his XYL is currently still around, and her call sign N6 Sierra Foxtrot Oscar. So what I'm going to do is write a letter to Carrie and maybe send a picture or two of this radio and explain how I came across this this little crystal plug knob here with some etching in there. And who knows, maybe there will be a part 2 of this video, or maybe Carrie is watching this. If you are, hello, and I just thought you'd like to know your husband's radio is at a new home now, and it's much appreciated. So anyway, back to the video. I hope you enjoyed it or enjoying it. Thanks. 7-3.